So now let's talk about probability. Probability it's like a murky word, but let's go ahead and start talking about delta because I like to use delta as my probability indicator. So if we think about the textbook definition of delta, it's really the options prices move for every $1 move in the underlying, which isn't the most fun way to think about options. So one thing that I harped on in our beginning options course is that a good way to think about delta is that snapshot in time is really the market's probability that the option is going to finish in the money. And that's really key. And as we move forward to the next slide, I want you to really think about that as we look at a snapshot. What is the probability that the market thinks this option is going to be in the money? So let's go ahead and look at our grid here and realize that as call strike prices decrease, well, what's going to happen with the delta? Well, the delta is also going to increase. Now remember, the owner of a call has the right to buy stock. So think about that. So if you're able to go and buy stock at a lower price, it would then make sense that there's going to be a higher probability that the option is going to finish in the money. Now, if you think about puts, though, as the put strike prices increase, right? So if you own a put, you have the right to sell stock. Well, as that strike price goes higher, you're able to sell your stock higher. Well, then it kind of makes sense that your delta would also increase, right? Because your probability that you're going to be able to be in the money, that your option is going to finish in the money, it makes sense. If I can sell things higher, there's a higher likelihood that this option is going to be in the money at expiration. So now that we're talking about probability, we really need to focus in on time decay. And just like you know about single leg options, time decay is very important. Now, when you sell options, time decay works in your favor, right? So time decay is always going to settle at 0 at expiration. Now, when you buy options, when you buy a spread, that time decay works against you, right? Because time decay is rapidly approaching 0 as you get closer to expiration. So keep that in mind. Time decay is very important when it comes to probabilities. So let's go ahead and look at a graph here. And on the x-axis, you have 100 to 0. This is referencing the days till expiration. Now, here, this slope line is time decay. So time decay is constantly approaching 0. It's losing value each day, and right up until about 30 days, you start to see time decay really accelerate as it's going towards 0. So imagine if you're a seller of options, this is actually going to be very beneficial for you, all things being equal. As opposed to if you're a net buyer of options, all things being equal, time decay really is working against you. Now, as we keep going through probability, let's go ahead and think about likelihood. And when I talk about likelihood, I want you, again, to think about the individual delta of each option leg to determine the in-the-money probability. And so by that, higher delta, higher probability of that option leg settling in the money. Vice versa, lower delta, I want you to think lower probability. Okay? Also, when we talk about likelihood, an easy way to think of this, if you're a net seller, premium acts as a cushion, right? What do we mean by a cushion? Well, if that premium, that extrinsic value of the option, keeps heading towards 0, it's working in your favor. It's a little bit of a cushion. Now, if you're a net buyer, that premium, that is extrinsic premium that's going towards 0, it's acting like a hurdle. The bottom line is, if you're a net buyer of a spread, you have got to make over and above what you're paying in premium before you make money, and time value has definitely got to be part of that equation.